Right, welcome. We are doing the topic application to calculus. The other name for application to calculus is optimization. All right, so what do we talk about when we speak about this topic? What is important for me is to understand that the concept of application to calculus works with function derivatives. So works with derivatives, function derivatives. So you have a function and you derive it. Deriving it is a way of studying the behavior and how the rate of change will take place. Now, let me break it down for you further. Listen to me. So when you're dealing with application to calculus, our issue is we have a function and we need to derive. And when there's a function and we need to derive, we are studying the behavior of that function and how the rate of change takes place. The rate of change takes place for that particular function. What is important is to be able to understand that application to calculus is applicable in almost all disciplines. You talk about physics, application to calculus is there. Economics, application to calculus is there. Engineering, statistics, medicine. The whole idea is to create a mathematical model. And once you create that mathematical model, you can then find optimal solutions by deriving it. Now, it may sound vague as we begin, but as we do questions, you'll become more familiar with this. So there are a couple of steps that you need to do. Understand that mathematically, when you have a typical function, you can represent the change in that function using a derivative. That is my first point here. You can represent a change in the function using a typical derivative. Then I said, when you are talking or interested about the rate of change, so the rate of change of any function comes when you derive it. So let's say I've got a function f of x, and I want to find the rate of change of f of x. It is as good as me finding the derivative of f of x. In that concept as well, when you want to find the maximum or the minimum of a certain function, you derive it and equate to 0, which is what the bulk of our questions usually ask us. They say derive and equate to 0 when you're looking for the maximum of a certain function, when you're looking for the minimum of a certain function. Then after that, you can solve for x. I'll take you through all these steps via a question. But the whole idea is to remember that rate of change in mathematics is finding the derivative of a function. And when you're looking for the maximum or the minimum of that function, is because you are deriving it and equating it to 0. Now, here's a typical question. Let's start using our brain. Please write this down. I'll send this handout to you. But it's a 2014 standard grade paper. It's paper 1 and it's question 7.3. And I want to deal with that quite quickly in that aspect. 2014 standard grade, paper 1, question 7.3. Let us begin. The question says, the sketch below shows the graphs of a hyperbola, g of x, which is 4 over x, where the value of x is greater than 0. And a straight line, which is h of x, which is 8 minus x for the formula. Point A lies on H and point B is on G. Let's discuss the diagram. Judging by what I see here from what's going on right there, you should notice that at the end of the day, someone's writing on my screen, please stop that. All right, please stop that. Okay, right, I've destroyed the access to it. Okay, now I'm ready for this. I am saying to you, when you look at your typical equation, or rather your graph, you've got this point is point A, which is on the graph of h of x. And also you have point B, which is on the graph of g of x. Now, one thing certain is that the point A and the point B are on a horizontal, or rather a vertical line. And so the value of x for A and the value of x for B is the same. What is different are their y values. So you'd expect that the y value for A is right here at the top, while the y value for B is down here. Typically in maths, the y value of A, since A is on the graph of h of x, will be h of x. That's what A would be. The y value for B, since B is on the graph of g of x, will just be g of x. They love these questions in paper 1 under the topic functions, where you're given a vertical line, and then from there on, you're supposed to come up with an equation for that vertical line. So when you're looking for the distance, and I'm reading the question right now, it says determine the largest possible vertical distance AB between the graphs of H and the graphs of G. Largest, another word you can think of is maximum possible vertical distance AB. Now, in all these questions, what you need to start with is to formulate a formula. You need to find the distance formula for AB. The x-coordinate of A and B is the same. And if that's the case, it means the distance AB becomes the top value for y, which is h of x, minus the bottom value for y, which is g of x. So usually we say it is top graph minus bottom graph. The graph at the top is the graph of A, and the graph at the bottom is the graph of B. And we say to ourselves, in such a case, if we're looking for the vertical distance, it is h of x, the top y value, minus g of x, the bottom y value. That will be your distance formula. All right, so let me get this right. It looks like to me AB is equal to h of x minus g of x. The x values are the same. The h of x is 8 minus x minus the g of x, which is 4 over x. Notice that when I put the negative, I put a bracket. Do the maths with me. We're just getting the formula. 8 minus x minus 4 over x. So in terms of the equation AB, the distance, it's 8 minus x minus 4 over x. But the question says they want the largest possible vertical distance, maximum. I gave an idea that when you're looking for the maximum, to get the maximum, you must derive and equate to 0. In other words, I'm going to say d of AB, derivative with respect to AB, d of AB to dx. So normally, you remember you would say for derivative, y is equal to 2x minus 3 as an example. Then you say dy over dx. But this time, we're saying to ourselves d of AB to d of x. So we're going to derive this particular equation equated to 0. That's what happens when it is at its maximum, or as the case says here, at its largest. Maximum or largest. All right, perfect. Let's do some maths here. So I need to derive this. And so I'm going to say to myself, okay, 8 minus x minus, I need to rearrange first, something like this. So that's still AB. Then the derivative would look something of this effect. Follow my lead. When you derive 8, it gives you 0. When you derive negative x, it should give you negative 1. Then I need to derive this power times coefficient, that's plus 4. Then that's x to the power negative 2. So this is the derivative. I can even write it like this. derivative of AB. But then we say we want to find out the largest possible distance between the graphs of H and G. So I need to derive this and equate to 0. So -1 plus 4 over x squared. See how I've changed it? 4x to the power -2 is now 4 over x squared. Then the rest is mathematics. So I can take the -1 to the other side. 4 over x squared is equal to 1. I need to solve for x, cross multiply. That means x is either plus or minus 2. So I've derived, I've equated to 0, I've solved for x. But question says determine the largest possible vertical distance that takes place between the graphs of H and G. So x has two values, x is plus or minus 2. But I was told earlier that the value of x should be greater than 0. So therefore, the value of x that I will choose is actually 2. So 2 is the value of x that I choose, but I want the distance, the largest possible distance. So I need to go back to my original formula and say, okay, the formula says 8 minus x minus 4 over x is the distance formula. According to what I've done, which is to derive and equate to 0, I found out that it is when x is 2, when x is positive, that's where I get my maximum largest possible distance. But what is that distance? I substitute back into the original formula, 8 minus 2 minus 4 over 2. And so your final answer, the largest distance that you can get here is 4 units. Now, listen to me very carefully. And let me just prick your mind a bit. This is what you do when you're dealing with turning points. When you deal with turning points, you're given an equation. I want you to see how this translates back to what we know. When you're dealing with turning points, you're given an equation, f of x, and then from it, you can derive that equation. And then from that one, you equate it to 0, solve for x. If you want to find the y value, you go back to the original. That's exactly what I've done here. Just that I had a concept of A and B, the distance. But the whole idea is to ensure that you form the formula and then derive it, equate to 0, solve for x, go back to the original, then you will notice that you will find out that your largest possible vertical distance is actually at 4 units. All right, let's keep going. You let me know where there's a struggle, where there's a question, or something of that effect. I'm ready. I'm taking this out now. This whole idea of A and B. All right, here's another question. I've got a lot of questions I want to do with you, okay? Lots of them. Here's another one, and I'm going to start on this one. So 2009 March, paper 1, question 13. Please write down the title for that one so that it can help you to prepare. All right, I'm ready for this one. Another graphing thing, but I just want to make sure that it's clear for everyone and we can do this the best way possible. Okay, here we go. Sketched is the graph of y is equal to t squared. Okay, sure. So the graph is of y is equal to t squared. The point A is t and t squared, while the point B is 3 and 0. Let me write them down. A, who are you? I am t and t squared. B, who are you? I am 3 and 0. And then the question says for 13.1, A, t and t squared is a point on the curve of y is equal to x squared, and the point B lies on the x-axis. Then it says, show that AB squared, that looks like distance again, but this time AB squared is exactly equal to what I'm looking at there. All right, I'm ready to break it down. This time, A and B are not vertical. They're not. So they don't have the same x coordinate, because if you were to think about it, the x-coordinate of A should be somewhere here, and the one for B is actually 3 and 0. So they don't have the same x coordinate. But then further on, I will notice that if I was to look for the distance, which is AB, distance formula says AB would be the square root of y2, or rather x2 minus x1, and then plus y2 minus y1. Basically, that's the long and short of it. So if you think about it, I could quickly say to myself, it is t minus 3 squared. So that would be probably x2 minus x1 plus, then we go t squared minus 0 squared. So that's basically the long and short. Then let me do my maths here because it's going to be a bit more exciting. Then I will say, okay, square root inside the brackets there, t minus 3 squared. I open up, so it's as good as saying t minus 3. I'll do it old school, t minus 3 plus t to the power of 4. Because notice that inside here, t squared minus 0 is t squared, but t squared squared is t to the power of 4. Then the rest is algebra, the most important topic that we have. Algebra, open up, t squared, I see minus 3t minus 3t plus 9 plus t to the power of 4. And still, that is AB. But then we can continue old school. AB becomes the root of t squared minus 6t plus 9 plus t to the power of 4. But I'm looking for AB squared. So let me square both sides. So then it's AB squared. When I square this side, it becomes t squared minus 6t plus 9 plus t to the power of 4. Then I rearrange, start with the t to the power of 4 plus t squared as they wanted minus 6t as they wanted plus 9. I did that for 2 marks because I wanted to show you the basics of everything, but this one is not a difficult question. So AB squared, the distance between point A and B, can be expressed in this way since I'm given the coordinates of A and B. 13.1. Write it down. I'm going for 13.2. Usually, after this, they ask you to get the maximum, the minimum, and so goes the story. You let me know if you have a question. You can just raise up your hand through the platform. I should be able to recognize you. All right, we're going to pitch it up a bit, up a notch, have a bit of more fun as we go on along. All right, I think people should be done now writing. I'd like to take this out as I get ready for 13.2. 13.2 says, hence determine the value of t which minimizes keywords. So it's important to, for me, it's very critical that we get the English proper. We then translate the English into mathematics. Hence determine the value of t which minimizes the distance AB. All right, somebody's got their hand. You can lift your hand through the platform. There's a part where it says lift hand, and then it will alert me, but I saw your hand. Let me unmute you. Go ahead. I'm listening. Go ahead.
So every time that the thing show that for example, education, you must always be
I can hardly hear you. I think there's, I'd rather type your question because I think the network is quite bad. I can hardly even hear you. So let me mute you. Then you can just type your question. Then I'll attend to it. While they are busy typing, let me work on it. Right. I'm ready for the next one. Hence, determine the value of t which minimizes the distance AB. All right, so AB squared is t to the power 4 plus t squared minus 6t plus 9. Hence, determine the value of t, which minimizes the distance. All right, so let's get this right. Every time I'm dealing with minimizing, I need to derive and equate to 0. They said AB, but let's get this right. AB squared AB, you will derive it in the same manner. So you'll say, in your case, the derivative of AB squared with respect to t, so it's dAB squared to dt, which then at the end of the day gives you 4t cubed minus 2t minus 6t. That's what you have, right? Rather minus 6, not even minus 6t, minus 6. All right, so that's what you have currently right there. Then we can go on further and then be able to say, okay, in this case, this derivative of AB squared to dt at maximum must equate to 0. So in other words, 4t cubed minus 2t minus 6, all this is equal to 0. And so now the key is finding t. The problem is that this is cubic, right? And so we need to have 3 solutions, but let's have some fun here. It looks like to me, I can divide everything by 2 if I wanted, so that I have 2t cubed right there. I think this should be a plus there. Oh, yeah, that's a plus. 2t cubed, and then plus, in this case, a t, then minus 3. That should equate to 0. Then I need to think about this. So remember, guys, 2t t squared here, when you derive it, is 2t, and then minus 6. Now, how do I factorize something like this? There's many options that you can pretty much take. There's many. There is that method that I taught most of you. Some of you maybe might be new to it. There's the synthesis method. You can take it up. There is the long division method. You can take it up, whereby you need to look for a typical a number that you can put for t, which will end up giving you 0. And so whichever method you use, you will end up here at t minus 1, then at 2t squared plus 2a, sorry, not 2a, plus 2t. Let me take this out. Plus 2t plus 3, all this is equal to 0. So this method of factorization, most of you guys know it. I cannot teach it now because I want to teach application to calculus. I want you guys to get this. T minus 1, then 2t squared plus 2t plus 3. That's basically how you factorize. Then it means then this is equal to 0. So it's like t minus 1 is equal to 0. So t will be 1. Then 2t squared plus 2t plus 3 is equal to 0. If you were to deal with this, you cannot find any solutions. So there are no real solutions for this particular part, which means at the end of the day, the only value for t, which will give you or minimize the distance, is when t is equal to 1. They never asked you to find the distance. They asked you to find the value that minimizes that distance. And so the value is t is 1. If they'd asked you for the distance, you'd need to have gone back into the original, substituted the value of t is 1, found your AB, that would be your minimum distance. But I'm saying it is only when the value of t is 1, that's when you've got your minimum distance in that one for AB. So that is your answer. And so write it down. Couple of hands. Let me just attend to the hands. that I saw. Oh, okay. All right, so I see that, okay, people are responding to the plus 2t, which is fine. I think that I'll sort it out. Write this down. Again, it's all about getting the equation, finding its derivative, equating to 0 if you're asked to find its minimum or its maximum. So I think the problem or the challenge comes in getting the equation or understanding the English of the mathematics. All right, somebody raised their hand. Let me attend to that. Make sure that hopefully your network is okay. I can hear you. Go ahead.
Hello, sir. I'm not sure if you can hear me.
I can.
So I have a question. My question is, I understand everything you did. I just want to ask, wouldn't we be finding or deriving the distance for AB squared, not AB?
No, okay. Let me clarify that. The way you derive the distance AB squared or AB is the same because you are deriving this part, right? Which is AB squared. And so if you're looking for the distance, we would have said square root of, if you're looking for AB, you'd have said square root of t squared plus t to the power 4 plus t squared minus 6t plus 9. But I'm saying whether you derive it as AB or as AB squared, you're getting to the same thing. And maybe it's a good thing that you asked this question. The derivative of the AB to dt and the other one for AB squared, which is what I'm doing, over dt, ultimately gets you to the same point. You're deriving this guy. So the same thing that you would put across here is how you'd put across even when it's AB squared. Hence, I went straight to AB squared. That's something that you guys must know, that the derivative there will ultimately get you to the same point. 4t cubed plus 2t minus 6. Then from there on, you can equate it to 0.
Okay, sir. Thank you.
All right, perfect. I'm going to my next one right now, and I'm taking this out. If there's any question again, let me know. Going. Another story. Remember, I said it's applicable in all aspects: physics, engineering, business, medicine. So goes the story when it comes to this topic. Here's a question from a 2023 Free State Prelim Paper 1, question 9. So one of the latest papers around. So let's run through it together. On the 2023 Free State paper, I'm ready. The window frame with dimension Y by H is illustrated below. The frame consists of 6 smaller frames. Okay, sharp. 9.1. If 12 centimeters of the material is used to make the entire frame. Get that right. If 12 centimeters of the material is used to make the entire frame, show that Y is a quarter 12 minus 3H. All right, let's discuss. So you have a window frame, and its dimensions are Y and H, and it consists of 6 smaller frames. 1, 2, 3, 4, 5, 6. But the whole big frame is this one. And then it says, we use 12 centimeters of the material to make the wall window frame. And so show that Y is equal to what you're looking at. Now let's agree. I've got 4 horizontal bars, 4 of them. 1, this one here, 1, then I've got this one here, 2, then 3, then 4. So I've got 4 horizontal bars, right? And each bar is Y, 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 Y. So I've got 4 Ys, 4 horizontal bars. Then on the vertical, I've got 3 vertical bars. So I've got this bar, which is H, and another bar, it's a window frame, which is H, and another bar, which is H. So I've got 3H. So all these dimensions, Y, for the 4 horizontal bars, H, for the 3 vertical bars, they all make up a material of 12 centimeters. So 4Y plus 3H is equal to 12. Let me know if there's a struggle. But I got 3 vertical and 4 horizontal. Then I need to make Y the subject because apparently that's what they want here. So the rest is just mathematics. So it becomes 4Y is equal to 12 minus 3H. And then I think now I can divide both sides by 4, which is now a quarter of 12 minus 3H. And for 2 marks, I have shown that this is what you have. Let me go back to the question so I can help you understand this. This is a window frame. A window frame, all right? Frame. So these dark parts, these lengths that you're looking at right there, hold on, let me spotlight them right there. These lengths, this one is Y. And you see this is Y at the bottom. So you got this length Y, another Y, the second Y, the third Y, and the fourth Y. 1, 2, 3, 4. 4 Ys right there. That's what you have, right? So then from there on, the 3 H's are 1, 2, and 3. These are bars of a window. That's what they are. So I got the 4Y plus the 3H, which ultimately gives me 12. And then from there on, I can just make Y the subject of the formula. And I've come to a conclusion that since I have 3 horizontal bars and 4 vertical bars, 4 horizontal, 1, 2, 3, 4, and 3 vertical, when added together, they should be able to give you 12, because they say 12 centimeters of the material is used. And that's what you have. And then I'm going to use this. For 9.2. Definitely going to use it for 9.2 to get my answers there. All right, I think it's clear. You let me know again where there's a struggle. Taking this out, gone. Show that the area of the window is given by that formula. So area of the window will definitely be the length times the breadth. So it's LB, the length times the breadth. So it's just going to be Y times H, length times breadth, or whatever you want to start with, YH in this case. So according to what I know, the value of Y is 1/4, and then 12 minus 3H multiplied by H. Okay. Somebody's asking me to repeat 9.1. Okay. These are bars. I think you guys are confusing this part. There's no window here. These are window frames. There are no glasses here. These are window frames. Get that through. These are window frames. I need to get that through, please. These are window frames. All right. There. 1, 2, 3, 4. These are Y. Y. 4Y. 4Y. Then the other one, I got your back. These ones, the vertical ones. 1, first vertical. 2, right there. Then 3, right there. So that's the third 3 of them. And all of them are pegging on H. So plus 3H. This wall material, this wall window frame is made from 12 centimeters of material, which is equal to 12. And then you make Y the subject. 4Y is 12 minus 3H y, divide everything by 4, is a quarter of 12 minus 3h. That's your answer. That's 9.1. And I was busy on 9.2. Hopefully people are understanding. Let me go to 9.2. Area of the window is given by, that's what they're asking. Area of the window and all. Somebody's asking, why do we end up with the quarter when we divide by 4? That's what you do. When you divide by 4, you end up with the quarter. Let me just explain to you. If I say to you 2 over 4 in maths, it's as good as saying a quarter times 2. That's what it means. 2 over 4 is a quarter times 2. That's exactly what it means. And that's why it's a quarter of 12 minus 3h. Or if you wanted, you could have done it this way. Let me show another way you can do it. Right? So you could have say to yourself, let me see, divide by 4. So that's 12 minus 3h over 4, which is as good as saying a quarter. 12 minus 3h. All right. Somebody has a hand. I want to pull that through. Go ahead. I've just unmuted you. Please say something. Okay, you've muted yourself, so probably it's fine. All right, I'm ready for the next one. The next one then says to me, show that the area of the window is given by this. Area is length times breadth. That's what area. This is just a typical rectangle. Y times h. That's what it is. Y times h. Notice that your area is given in terms of h everywhere. And in the previous question, I know what y is in terms of h. So y in terms of h is a quarter of 12 minus 3h. That's what y is. But all this is multiplied by h. This then you can then play around with maths. Let me give you just an example. If I say to you x times y times z, it's as good as saying x times z times y. I can always move this x because they're multiplying. Or it's as good as saying y times x times z. You can start with any. As long as they're multiplying, you are free to play around with the terms. Now, I would like to move h to go in front so that it becomes a quarter of h, 12 minus 3h. And then eventually, I want it to end up the way that they wanted. A quarter h times 12 is as good as saying 3h. Quarter h times 12 is 3h. Then minus a quarter h times minus 3h is minus 3 over 4h squared. And that is the area. Just like what they wanted, the area of the window is given by that. I tell you this again, algebra. I tell you this again and again, algebra. That's your guy. 9.3. 9.3 for 5 marks. It's a 2023 paper, so something quite recent. And we're doing a variety of questions. All right, I'm ready for 9.3. It says find dA over dH. All right, and hence the dimensions h and y of the frame so that the window is a maximum. Once I hear the word maximum, I know what it means. They want us to find dA over dH. Okay, let me work on it a bit. The previous question showed me that A is 3h minus 3 over 4h squared. That's what A is. And so if I'm looking for dA over dH, that's me deriving. So it's the concept of A and H. So when I derive this, 3h is 3. When I derive this, its power multiplies coefficient. So that's like 2 times 3 over 4, which is negative 3 over 2, power minus 1, h. That's dA over dh. And hence, find the dimensions of h and y so that the area of the window is at a maximum. So when I say maximum, the idea is that the derivatives will equate to 0. Every time we deal with maximum, derivatives are hanging on 0. So that means 3 minus 3 over 2h equated to 0, maximum. And then from there on, you can do the maths. 3 is equal to 3 over 2h. Can cross multiply. 6 algebra. That means the value of h is 2. And that's the only value that we have. So which means h is 2. But they said find the dimensions of h and y. At least I know what h is. Then from the first question, we also know that y can be written as a quarter of 12 minus 3, but the h is 2. I want to find y now. And when you do your maths, the value of y is 3 over 2. So the area will be a maximum only when the value of h is 2 and ultimately the value of y is 3 over 2. All right, let me know again where there's a struggle so I can be of assistance to you. But I think you with more practice, you'll be able to get the hang of this to say, okay, do I have an equation? Yes. Can I derive it? Yes. Go ahead. Somebody has a question.
I said, I'm not sure if you can hear me.
I can hear you slightly. Go ahead.
Okay. Okay, I didn't have a question as such. It was just a different method for like 9.2, right? So what I first did was find the area of one of the smaller frames itself, and then after that multiplied by 6, and then it gave me the same answer. So I don't know if you could like do the same method just
No,
to
that's
break
fine.
it down for everybody to see.
Yeah, that's okay. But it's a very huge assumption though that you're making, because you are assuming that well, because it's a window frame, the frames of or these areas here are pretty much the same. That's why you're able to multiply by 6. Okay, this should be equal to that and all. Okay, that's all good and well. I will take that from there. So I will take that. Let me try my next one, more interesting than previous. Let me know again if there's any question. Somebody raise their hand. The easiest one is the one that I just put across, length times breadth, length times.
Hello, sir.
Hi.
I wanted to ask, when you substituted the h equals to 2 into y, why don't you substitute it into the a instead?
If I substitute
Because when you
a, I will end up getting the maximum area, right? But they said find the dimensions of h and y. That's what the question is. Hence, find the dimensions of h. So I noticed that when h...
Oh, we were looking for the y value.
Yeah, and h, yes.
Oh, okay.
Perfect.
Thank you, sir.
Anytime. All right, let's go to our next one, fam. I am moving with you, and we are moving together. Here we go. What's my next one looking like? Nazo? So 2015 Gauteng Prelim Paper 1, question number 12. Let's go for that one. It's an interesting story, so let's read on it and what it is saying. Like I told you, this topic is applicable in all aspects, and here we are applying it in profit, in business. The story. The profit P in runs per day, which the owner of a taxi makes when the taxi is driven at an average speed of X kilometers per hour, is given by this formula. So this is the formula for the profit. that a certain owner of a taxi will make when the taxi is driven at a certain average speed right there, X kilometers per hour. And then the first one says 12.1, calculate the average speed at which the owner will make or will suffer a loss in revenue. All right. Will suffer a loss in revenue. Now let's think English, translate English into maths. The profit is given by this formula. And if the owner is to suffer a loss in revenue, that means he does not make positive numbers. He doesn't make positive profit. The profit is less than 0. In other words, look at this. P, profit made, or rather P is negative. So when you say profit is negative, you're not really saying profit is negative. You're just saying you made a loss. That's what it means. You made a loss. So the question says, what is the average speed? And the average speed is X, by the way. What is the average speed at which the owner will suffer a loss in revenue? Let me give you context. The faster you drive a car, the more fuel it burns. And if you are a taxi driver, you are traveling at very high speeds. That means you are using a lot of fuel. And part of the expenses of the business of being a taxi owner is fuel. That's part of the expenses. So the more fuel you end up buying by driving at high speeds, the less profit you end up making, because now your expenses are now greater than your income. So you now are on negative. So the profit is negative, or rather there is a loss. I'm trying to make you understand when I say profit is negative, that's a mathematical term. But when you speak about it in the context of business, when profit is negative, you're simply saying, I am making a loss. That's all that I'm doing. So then profit equation says X squared, all right, 40 minus X over 3. And if I'm making a loss, it must be less than 0. The rest is maths algebra. You're looking for X, the average speed. So then if I divide both sides by X squared, I'm good. I'm remaining with 40 minus X over 3 less than 0. I can divide both sides by X squared. Then 40, do the maths with me, right there, less than, and then X, okay, I can do this. Let me do this so I can show you something in inequalities as well. Let me say negative X over 3, that's less than negative 40. I've taken the 40 to the other side. Then I can cross multiply. Now I've got negative X, that is less than negative 120. Then now, because there's negative on both sides, I can divide by negative 1. And every time you divide an inequality by negative, please know that the sign will change. That's why I ended up taking that route. X is now greater than 120. So it looks like, as a conclusion, if the driver drives at a speed that is greater than 120 kilometers per hour, definitely we're making a loss. So that's your answer for 12.1. When the speed X is greater than 120, that's when you make a loss. Let me know if there's a struggle again. I got your back. I want to hear what you guys have to say. Okay, let me attend to one of you. Go ahead.
Hi, sir.
Hi.
I have a question.
It's fine.
With regards to when you transposed the 40 instead of the X divided by 3, would I be wrong if I transposed that instead of the 40?
You'll be correct. Very correct. You'll end up getting the same place. I just wanted to show you guys and remind you that when you divide by a negative, the inequality sign will change, but otherwise you'll be fine. Okay.
Oh, okay. Thank you.
Perfect. All right, I'm ready for my next one. Let's go, 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 go. Right. Let's hear the English, translate the English into mathematics. The story as follows. Calculate the most economical average speed of the taxi and the corresponding daily profit. Can we translate English into maths, please? Most economical average, so the most minimum that you can travel with, and the daily profit that comes with it. Most economically average. So it looks like to me I would probably need to then derive and equate to 0. Then they said, and the corresponding profit. Profit, I'm opening the brackets, 40x squared. So x squared times 40 there. Then you got x squared times negative x over 3, which ends up as negative x cubed over 3. That's basically the profit. And then now we're saying if it's economical, then it means the derivative of p with respect to x, look at what I'm doing, is 0. Or I could have said dp over dx should be 0 at the most economical. Then from there on, I can quickly pick up my story and then say to myself, okay, dp is 0 right there. Then that means at the end of the day, I will end up with 40. Let me look for something else. Different color. This is too thin. Sorry about that. Give me a second. All right. So you got 40x squared minus 1 over 3x cubed. I'm still on this part. I haven't done the derivative. I'm just still showing you that p can be written like this. Then now when you're deriving, you will then say to yourself, the derivative will be 80x minus, right, a third multiplied by 3, that's negative 1, or negative a third times 3, that's negative 1, and then power minus 1. So it becomes x squared. I'm just deriving. So all this is equatable to 0. Then now I need to solve for x. There you are. That's 80 minus x is equal to 0. That means x is economical at 0 kilometers per hour, which doesn't make sense because the taxi won't be moving. 80 minus x is 0. That means the most economical average speed is 80 kilometers per hour. It's only when we're moving at 80 kilometers per hour, we are at the most economically advantage or average speed. Then the question says, and calculate the daily profit. So if I'm moving at 80 kilometers per hour and I want to find the daily profit now, I need to go back to the profit equation and say, I know for a fact that at 80 kilometers, I'm at my most economical speed. So P becomes equal to 80 squared, then 40 minus where there's X, I'll put 80 over 3. I would like to know how much I'm getting. I probably am getting 21,333.33 rands per day if I travel at the most economical speed. And that's how the taxi guy, Ubabu Dlamini, Ubabu Shabalala, makes his money. All right, so that's what you have there. 21,333.33 runs per day. All right, let me know where there's a struggle, fam. The whole idea is to find out how to derive equate to 0, and we take it up from there. I'm ready for my next one. Somebody says that's not the answer when punching, so let's let others try as well. Tell me what the answer is. So no, remember it's cubed. Ugh, why did I forget this? It's cubed. There, I need to x there. I put it like this. I go family. Tell me, is it not? Let me go back. I did not calculate this myself, so I'm just taking it up from somewhere. That's 40 minus whatever number. Give me the number that you have. 80 over 3. Are we getting the same answer? 85,000. Okay, cool. That's even better. Right. Confirm the numbers. Thank you for confirming them. 85,833. 85,833. 85,333. Let me see. Okay, sharp. Yeah, I think when I put it like this, it works. Okay, I'm taking this out. Just recheck the answers. Thank you for rechecking them. I'm going to my next one. Now, I'm going to do 2 more questions, then I'm going to give you stuff to try just to see if you're on the right track or not, or if there's any question. Here's a 2015 Northwest paper, and I want you guys to really get to understand how this question works. Now, it has components of physics. Yes, physics. You heard me right. Particularly the topic vertical projectile motion. So these are the components. Those that don't do physics, listen to me as I teach you and help you to understand all of this. 2015 Northwest Prelim, paper 1, question number 8. Definitely, it's a lot of physics. A stone is thrown vertically upwards. Okay, so just imagine this. Like, imagine this in your head. So a stone is thrown vertically upwards. So this is the stone and it is going upwards. So keep that in mind. It's going upwards. Okay, sharp. Its height in meters above the ground at time t is given by this formula. So the h is the height of the stone above the ground. The t is time in seconds. So the formula for the height of the stone above the ground at a certain time is this. Sharp. The first question says, determine the initial height of the stone above the ground. Now, I want you to interpret the English into maths with physics involved. So listen to me. Determine the initial, the start height. How high was it when we first threw it above the ground? So initial translated, initial happens in the beginning when time is 0. So the initial height is found when time is in the beginning. So when time is 0, when you threw it the first time, right? When time was 0, we want to find the initial height. Okay? So therefore, at the end of the day, it's just going to be h of 0. In normal calculus, when you're dealing not application, sketching of cubic graphs and blah blah. Every time you say h of 0, you're just looking for the y-intercept, and it's always the last number there, and that's 32. But let's do the maths. So it's going to be negative 2, that's 0 squared, plus 12 in the beginning, plus 32. So then we were 32 meters above the ground when we threw this particular stone. So I want you to get the idea. Initial means time is 0. Initial height, initial time is 0. That's all. Initial time is 0. Initial time is 0. All right, 8.1 done. 8.2, I'm just teaching you maths, physics, and application to calculus all brought up together. All right, you'll be fine. Don't worry, it's just this part, nothing too hectic after this. Determine the time taken to reach the maximum height. Oh, I love this one. Determine the time taken to reach the maximum height. Now, listen to me and listen to me very carefully. When the typical stone is thrown upwards, it moves up, 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 then somewhere it will stop. Where it has stopped, that is your maximum height. Where the stone has stopped, that's your maximum height. So it will stop, maybe let's say somewhere here. I said stop, that's English. But in physics, in maths, we're saying the velocity of the stone is 0 meters per second. So when the stone stops, we're saying its velocity or speed is 0. And here's what I want to teach you. I want you to understand that the speed is actually the derivative of the height with respect to time. Those that teach physics, when you define velocity, you say velocity is the rate of change of displacement. Rate means derivative in maths. Rate of change of displacement with time. When you define acceleration, physics guys, hang in there, you say acceleration is the rate of change of velocity. Acceleration. So in this case, velocity, the speed, is the derivative of the height. I want you to remember this. Velocity V is the derivative of the height. And the question says, determine the time, 8.2. Determine the time taken to reach maximum height. I need to know how long it took me to get to my maximum height. So I've got the formula for height. Let me get the formula for velocity. All right, negative 4t plus 12. I've derived. That's the formula for velocity. But what do we need? We need the time taken to get to the maximum height. The time taken to get to the maximum height is found when the velocity is 0 meters per second. Or if you want, again, remember, maximum height, you derive and equate to 0. When you're deriving h of t, you're just looking for velocity. I'm just combining maths and physics so it can make sense. So therefore, the derivative of h of t is equal to 0, or the velocity, negative 4t plus 12. They want the time taken. So it must be equal to 0. Negative 4t is negative 12. The rest is maths. Divide everything by negative 4. 3 seconds. That's how long it takes to reach the maximum height. 3 seconds. All right, let me know if there's a struggle. All right, I'm ready for my next one. So we'll keep learning and all. So when they say determine the time taken to reach the maximum height, maximum, I say derive, equate to 0. Just all. All right, just derive and equate to 0. That's what I'll teach a class of students that do maths only. I'll say to them, derive and equate to 0. Maximum height, derive, equate to 0. Then when the students that do maths and physics, which is the bulk of you, then I'll say to you, listen up. When you throw something, it goes up and it will stop. Stop English, physics, maths, stop. Velocity is 0. I stopped. My speed is 0. I stopped. My velocity is 0. Okay, sure. I stopped. Then I'm saying to you, the derivative of the height is actually your velocity. And when the velocity is 0, when it has stopped, it would have reached its maximum height. It can't go further than this. It can't. It has stopped. It can only go down. So therefore, at maximum height, the derivative of h of t, or the velocity, is 0. And the question says, how long does that take? So I derived, equated to 0, solved for t. 3 seconds, that's all it took. All right, so keep that in mind. Velocity is the derivative of the height. And I'll give you a question, hopefully something on that aspect. I'm going for 8.3, logic again, 8.3, 5 marks. Work with me on 8.3 on that one. All right, stop me where you don't understand. Maybe just even raise your hand. I can assist you. How fast? All right, how fast? Fast is velocity. Velocity we call it as negative 4t plus 12. How fast was the stone traveling when it hit the ground? Let's think, Buffett. How fast was the stone traveling when it hit the ground? Okay, here's the logic. Here's the logic. Work with me. The stone was here. We threw it. It went up, 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 reached its maximum height after 3 seconds. Went down, 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 down. Remember, it was above the ground, so this will be the ground. So it went down, 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 down. Then it hit the ground. And the question is, how fast was it moving when it hit the ground? Remember, when we threw it 32 meters above the ground. That's where we threw it, from 8.1 initially. It went up to the maximum height, then came down to the ground. And the question is, what or how fast was it moving when it hit the ground? Now, work with me. Think with me. If the object is to hit the ground, the stone is to hit the ground, then it means its height at the ground is 0. Because at the ground here, your height is just basically 0. When you're at the ground, your height is 0. Talk to me. Height is 0 when you hit the ground. So which means the formula for height is negative 2t squared plus 12t plus 32. When this formula is equal to 0, guys, do not mistake derivative of h of t is 0 and h of t is 0. Those are two different things. Here I said when I'm at the ground, when I'm at the ground. So at the ground, right? H of t is 0 when I'm right at the ground, which means the height formula is 0, because it means when I'm at the ground, I'm at the lowest point of them all, and so my height is definitely 0. All right, so from there on, then I can equate this to 0, then solve for t. But I'm not looking for the time taken to reach the ground. No, 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 no. I'm looking for how fast it takes to reach the ground, not the time taken to reach the ground. So then I need to solve for t, divide everything by negative 2. So this becomes t squared minus 6t minus 16. All this is 0. Then I can factorize. It's a quadratic equation. That's my 0 there. So I've got the negative 8 and I've got the positive 2 right there. And then I will say t is equal to 8, or the time is negative 2. But hold on, there is no time that is negative. Time can never be negative. So therefore, at the end of the day, you're going to have a situation whereby the time taken to reach the ground is 8 seconds. Time negative is not applicable. But hold on, we're looking for how fast. How fast? How fast is velocity? That's how fast it is. And the formula for velocity is negative 4t plus 12. I found out how fast it takes me to reach how long rather it takes me to reach the ground. I can find out how fast it takes me to reach the ground. Then T right there. And my answer is negative 20 meters per second. Speed is measured in meters per second. Negative tells me that I'm moving 20 meters per second downwards. That's what negative tells me. Physics guys, this falls into your laps. Maths guys only, you'll get this right. It's not difficult at all. That's how fast things are. Write this down. All right. Somebody raised their hand. I'd like to attend to that. Go ahead.
Hello, sir.
Hi.
May you please explain again why we're substituting the time into the first derivative instead of the original, which is h of t?
Because we're looking for how fast. If we're looking for the height, we'd go back and put it in this. And if you put t as 8 here, you end up with 0. So you're looking for how fast this thing is moving. And the formula for how fast is velocity, which is negative 4t plus 12.
Oh, okay.
Yeah.
Thank you.
Looking for how fast it's moving. Right. So that all done and dusted. Let's go to our next one. All right, somebody has a hand. I'd like to deal with that. Go ahead.
So I wanted to ask, how do you know that you have to use v is equal to negative 4 plus t?
It's because they told me that they want how fast, and how fast is velocity. And velocity is a rate of change of height, which is negative 4 plus 12. How fast? That's velocity. What is velocity? Is rate of change of height. What is rate of change of this guy? Negative 4t plus 12. So I needed to find the time taken to reach the ground. Then I'll find how fast it gets to the ground. So remember the concept is that there's a lot of things happening here, because when you're dealing with movement of anything, you're concerning yourself with how long does it take to move? That's time. You're concerning yourself, how far does it go? That's height. You're concerning yourself, how fast is it moving? That's velocity. And I want to relate these concepts all together and say to you, in a case whereby you are dealing with velocity, it is the first derivative of height. And when you are at the ground, the height is 0. When you're at the ground. When you're starting to move, your time is 0. Oh my word. Watch this when I put it on YouTube. Listen to my words. When you're starting the movement, your time is 0. When you're on the ground, your height, h of t, is 0. When you want to know how fast, that's your first derivative, h of t. Are we together? Get me on that part there. How fast is the first derivative? And the question was, how fast? How fast is this thing going? All right. Write that one down and all. I'm ready for my next one. (8.4) Determine the acceleration of the stone. Now, I want to write what I was saying quickly, but just this part. H of t, that's the height. Derivative of h of t, that's the velocity. second derivative of h of t, that's actually acceleration. And we're learning, because when you define acceleration, you say acceleration is rate of change of velocity. That's what you say acceleration is. Rate of change of velocity. I appreciate the beautiful messages that I see. People are saying, yo, say, Yazin, fit. You're the goat. That's the goat. All right, I love it. But the point is on this one. It says here, the rate of change of velocity is acceleration. When you derive twice, that's acceleration. And so from question 8.2, I was able to derive for the velocity. And so if I want acceleration, I need to derive twice. And your answer is just -4. Acceleration is measured in meters per second squared. And that's your answer for that one. Write it down. Somebody has a hand. Go ahead.
Hello, sir.
Hi.
Can you hear me?
Loud and clear.
I wanted to ask that, is it always going to be this case when it comes to VPM that the first derivative is velocity and the second derivative is acceleration?
Yeah, if you're given height or movement or distance, that's always the case. That's how you define them in physics. This is why when you measure height, velocity, you say meters per second. Meters, but that's the derivative. So meters will be distance over time. And that's rate of change of distance with time, or rate of change of height with time. And when you say acceleration, you say meters per second squared, because now you're saying velocity with time. So velocity with time, which gives you meters per second squared. So that's what happens when you get to that. All right, I'm done with that one. So now at least you have an idea of how this is done. And all. Somebody says, but say, will I be wrong if I say height is equal to the derivative of velocity? No, you're not. Sorry, if you're saying what? Let me read that again. If you're saying acceleration is equal, yes. Will I be wrong if I say acceleration is equal to the derivative of the velocity? You will not be wrong. That's what I've been saying. Acceleration is the derivative of velocity, or the second derivative of height. Because the story starts with height, velocity, acceleration. Height, velocity, acceleration. In physics, we become more specific than this in physics. All right, fam. Let's try this one here. I want to give you this one to try. I'm going to just tag you on this to try this, please, quickly. Let's see how far it goes. I'm going to give you about 5 minutes. Try this one. Let's see. Here we go. All right, I think people should be done. If there's a struggle, I got your back on that one. I am ready to help you. Interesting question, so let's go for it. What is it saying? What is it saying? All right. The question says, in the accompanying figure, PQR is an equilateral triangle. For me, that's key. That's key. It's an equilateral triangle with sides 12 units long. So it suggests to me that from here to there is 12 units long. STUV is a rectangle inside the triangle as indicated, with QV is equal to UR is equal to X. Now, when it's equilateral rather, it means from Q to R is 12, from P to R is 12, from P to Q is 12. All the sides of an equilateral triangle are equal, and even all the angles are equal. So when I say all the angles are equal, it suggests that here, this angle is 60 because all the angles in a triangle add up to 180. This is 60 as well, and this is 60 as well. Now, we're told that QV is X, UR is X. And so the whole of QR. So let me just clarify this. I'm going to show you this. So from Q to R, the whole of QR is 12, right? So QR is 12, QP is 12, PR is also 12. And from that perspective, if that's the case, then what it means is that at the end of the day, the distance QR, which is 12, gives us VU, which is 12 minus 2x. Aibo, 17, back. QV, go to, not QV, QR. Let me take this out. Oh, this is interesting maths. Higher grade is fire, right? So QR, who are you, QR? I am QV, look at it, plus VU, all right, plus UR. That's what QR is. QV, VU plus UR. Then QV is X. They told us there. VU, don't know. UR is X. That means QR is 12 because that's 12. Then X plus X is 2X to the other side. 12 minus 2X is equal to VU. That's VU, 12 minus 2X. And because it's a rectangle, STUV, that means this top part is also 12 minus 2X. What I don't know is TU. I don't know TU. I also don't know SV. But let's do math and be very clever. Look at this. Look at this. It's a rectangle, eh? It's a rectangle. So the angle here is 90. And the angle here is also 90. So now if I consider SQV, it's now a right-angled triangle. If I consider SQV, where this is 90, this is X, and the angle here is 60. The question for 7.21 says, prove that the area A of the rectangle is given by this. So the area of the rectangle SVUT is given by that. Okay, hold on, follow me. I know VU. I know VU. I don't know SV. SV, I don't know you. TU, I don't know you. But SV and TV are the same because they're opposite sides of a rectangle. I can get SV. I can. This is my opposite side. QV becomes my adjacent side. 90 degrees is a right-angled triangle. Tan 60 is opposite, which is SV over adjacent, which is X. Then that's X tan 60 is equal to SV tan 60 special angle is root of 3. So that's x times root of 3, which is equal to SV, or you can say root of 3x, which is SV. So now I have SV. I'm looking for the area of the rectangle. Area is length times breadth, which in this case, I can say the root of 3x multiplied by, I need root of 3 is SV, multiplied by 12 minus 2x, which is your VU. And that's how you get 3 marks. Talk to me. Talk to me. Azo, who got it? Yeah, ne. Did you think along those lines, Buffett? How was this one? Somebody got it? Perfect. Very proud of you. Others got it as well. Equilateral triangle. We got that. We understood and all. Perfect. Somebody says couldn't find SV, but now you know how to find the SV. So that's 7.2.1 all done and dusted. Somebody says I was on my way. I believe you. I so much believe you that you're on your way. All right. Let's go further on this one. Right, if you have any question, clarity that you need, let me know. I got your back. Okay, I'm ready for my next one. The next one, I think now works with what we have. Taking this out. Determine the maximum area that the rectangle can assume. Okay, let me take this out. All right, so we're just looking for the maximum area, and I think now we know that when it gets to maximum, we are clear that we are going to be having it as a derivative and equated to 0. Maximum area. Okay, I'm ready for the maximum area. So area as it stands is root of 3x multiplied by 12 minus 2x. At maximum area, dA over dx should be 0. Let me see if I can open up the brackets. So root of 3x times 12 is basically 12 root of 3x. And it is 12 times root of 3 times x minus root of 3x times minus 2x. That's going to be negative 2 root of 3x squared, because the x and the x. Now I'm looking for dA over dx. When you derive this part, imagine you're deriving 3x, just as an example. The answer would be 3. But this time you're deriving 12 root of 3x. The answer is 12 root of 3. Minus, we derive here. So your coefficient is this. Here your coefficient was that. Power times coefficient, that's minus 4 root of 3x. This must be equal to 0 when you are at your maximum. Determine the maximum area, that's what they're looking for. Let's get the value of x. 12 root of 3 is equal to 4 root of 3x. Algebra. I can divide both sides by 4 root of 3. Then I think I can get my value for x as 3, but I'm looking for the area. So the area, we go back to the original equation. Area will now be root of 3 multiplied by 3, then brackets 12 minus 2 multiplied by 3. Your final area is 18 root of 3 square units. And so that becomes your answer. Somebody says, aren't we supposed to get rid of the square root when deriving? No. Let me show you. I think you're making a mistake. You're thinking the square root is with x. X doesn't have a square root. It's not like this. This is not like this. It's like this. X is on its own. The power is 1 here. So the power is 1. Power times coefficient. So I'm saying the coefficient is this. The power is 1. The coefficient is this. The power is 2. Power times coefficient, power minus 1. So that's basically what you have there. So that's your answer for that one. Sorry about that. I took it out. Yeah. That's your answer for that one. And that becomes the story. Okay, so let's try another one together again. We are learning. We are picking things up nicely. Let's see how far we can go. I'm hoping people got this right. Okay, somebody raised their hand. I'll attend to that. Go ahead. Okay, I think someone was raising that they got it. It's fine. Happy about that you got it. And all right. Next one, please. Next one, algebra gone. This is what the next question is all about. What are we learning on the next one? Okay, 2010 November, paper 1, and that's question number 10 on that one. Let me do this with you, then I'll give you the next one to try on your own. Then we pick it up from there step by step. I like those old questions. They're quite challenging, and they give you more broader perspective of the topic. 2010 November, paper 1, question 10. I read in your hearing, and I do it with you. All right. The story. A satellite is to be constructed in the shape of a cylinder with a hemisphere at each end. The radius of the cylinder is r meters and its height is h. Yo, listen to this one more time. Let me read this. A satellite is to be constructed in the shape of a cylinder with a hemisphere at each end. So they try to put the diagram for you to show that this will be the hemisphere. The radius of the cylinder is r meters and its height is h meters. See the diagram below. The outer surface area of the satellite is to be coated with heat-resistant material, which is very expensive. The volume of the satellite has to be pi over 6 cubic meters. So volume of the satellite is pi over 6 cubic meters. All right, I'm ready. Follow my lead. Show that h is 1 over 6 r squared minus 4r over 3. H. Now, let's gather the information that we have. Please work with me, fam, on this one. Let's gather the information that we have. The information that I have is that I have the volume of the satellite, which is pi over 6. But the satellite is made of 2 shapes. It's made of this shape, which is a hemisphere, and this other hemisphere, and then the cylinder part. So I've got 2 things going on here. I've got 2 hemispheres and 1 cylinder that makes the satellite. Hemisphere means a half a sphere. When you got 2 half oranges, it's 1 full orange. Keep that in mind. 2 hemispheres is 1 full sphere. So the volume of the satellite is equal to the volume of the sphere. When I say sphere, it's because I've combined the two hemispheres and the volume of the cylinder. That's what I know. That's what I can see. Two half oranges, two half hemispheres are going to give you a sphere, and then the other part is the cylinder. They gave you formulas in this question. They gave you the formulas of the volume of a sphere and the volume of a cylinder. Now, the volume of the set light we're given is pi over 6. Let's do some algebra here. Pi over 6. The volume of the sphere that we are given is of the formula 4 over 3 pi r cubed, and the volume of the cylinder we're given is going to be pi r squared h. All right, let's do some serious math, beautiful math that we're going to do right now. Follow my lead. Okay, so the volume of the set, again, the volume of the set light is the volume of the sphere, which is 2 hemispheres plus volume of the cylinder. We're given that the volume of the set light is pi over 6. The volume of the sphere there, pi 4 over 3 pi r cubed, and the volume of the cylinder is pi r squared h. We're supposed to make h the subject of the formula. H, maths, pi over 6 minus 4 over 3 pi r cubed is equal to pi r squared h. Since I'm looking for h, I can make h the subject of the formula. So I can divide both sides by pi r squared. I can. In other words, this becomes pi over 6 over pi r squared minus 4 over 3 pi r cubed over pi r squared, which is equal to h. Then I can say pi over 6. Now, hold on to this. Follow my lead, please. Don't get this wrong. Let me have this way. Let me just erase this part. Okay, perfect. Now, listen to me. I got your back. I'm coming to you. I see your hands. Pi over 6 over pi r squared minus 4 over 3 pi r cubed over pi r squared. Now, this is as good as saying pi over 6 times 1 over pi r squared. This pi r squared is like pi r squared over 1. Then the division sign becomes a multiplication. Then you tip and times. Okay? Minus at the top, 4 over 3 pi r cubed, again tip and times 1 over pi r squared. All this is equal to h. Then the math happens. This and this cancel out. I'm left with 1 over 6 r squared. This pi, that r squared, that r cubed. I'm left with the r at the top. That becomes minus 4r over 3. All of this is equal to h, just like they wanted. That's your answer. Now I can take your hands and see what's going on. All right, let me hear the first one. Go ahead.
So, sir, hi.
Hi.
I hope you're good. I was confused there by the sphere because there's 2 spheres. So I thought we should multiply by 2.
It's hemispheres, not spheres. Hemispheres.
Oh,
Look at it.
okay.
Here, hemisphere.
Okay.
Yeah.
Thank you, sir. Now I understand.
Okay. So it's 2 hemispheres. That's why it makes it 1 sphere. So the set light is 2 half spheres. And then from there on, those 2 half spheres will now make 1 full sphere. And your answer for that one is that. Talk to me. Talk to me. All right, I'm ready for my next one. It's a very interesting question that we just did. I think there's more. This is just the 10.1. There should be more coming up after this. All right, somebody's asking me to repeat. Which part are we guys struggling with? Because a satellite is made of two hemispheres. Hemi means half. So that's half a sphere, two half oranges gives you one full orange. Two half hemispheres give you a sphere. The satellite is made up of a cylinder and two hemispheres. So that's like a sphere and a cylinder. The volume of the satellite were given pi/6. The volume of the sphere were given 4 pi r cubed, 4/3 pi r cubed. The volume of the cylinder were given pi r squared h, right? So that's basically what you have. The whole idea is to just make h the subject of the formula. And so what I did is I then took out to be pi/6 minus 4/3 pi r cubed. It's called pi r squared h. Then I divided both sides by pi r squared. That's all. Divided this side by pi r squared. I divided that side by pi r squared. It's like saying 4/3/2. You know it's going to be 4/3 times 1/2. This pi r squared is like pi r squared over 1. Then you tip in times. Then they cancel out, and eventually you're supposed to pull through. There is no rectangle. It's a cylinder. This is a cylinder. It's a cylinder. It's not a rectangle. It's a cylinder. This whole shape, cylindrical, and then the hemispheres at the end. That's why they gave you the formulas of sphere and cylinder. All right, I'm ready for my next one. Let's see what the next one says. Taking this out. Gone. They're gone. Okay. Let's see what the next one is saying. Hence, show that the outer surface area of the satellite can be given as this. So they want me to show that the outer surface area of the satellite can be given by that formula. Let's try and see how far we can go. As we stand, let me just take you back a bit, maybe just in case. The formula for surface area of the sphere is 4 pi r squared. For the cylinder is 2 pi r h. So this formula is you're given. All right, so let me just go back and see how far we can go. So the surface area, sorry about that. So the surface area is the surface area, or the surface area of the satellite is the surface area of the sphere plus the surface area of the cylinder. And we're given those formulas. I'm just going to write them down for you just in case you're struggling to actually remember them. Not a problem. So it's going to be, in this case, the surface area of the sphere. Just give me a second. Maybe let me write it down from the other part. It becomes easier. Then I can pull it up at once. Okay. Let me take this out. Okay, perfect. And I'll write it here. So the surface area of the satellite is the surface area of the sphere plus the surface area of the cylinder. The sphere has a surface area of 4 pi r squared. The cylinder is 2 pi r h. And then we know that h is this from the previous question. So then we can say 4 pi r squared plus 2 pi r, what is h? 1 over 6 r squared minus 4r over 3. That's what h is. So then this becomes 4 pi r squared, then 2 pi r times 1 over 6 r squared. So maybe just do it on the side so that you are not confused. Times 1 over 6 r squared. I think the r and the r, they cancel out. So I'm left with the r at the bottom. Then the 2 and this one, they cancel out. I'm left with the 3 at the bottom. So the pi is at the top over 3r. So this becomes plus pi over 3r. Then minus, this is now 2 pi r times negative 4 r over 3, which is negative 8, right? Pi r squared over 3. Again, it would have been 2 pi r multiplied by negative 4 over 3r. The 2 and the 4, they give you 8. Pi is on its own. Then r and r squared over 3. Then that's the negative part. There you are. Basically, that's what you have. But that's not what they want. Because I'll show you this. Look at this. This and this are like terms. They are. 4 pi r squared minus 8 over 3 pi r squared. Imagine this in simple maths. Imagine this as 4x minus 8 over 3x. 4 pi r squared minus 8 over 3 pi r squared. It's like 4 minus 8 over 3. That's how you do it in math. You'd say 4 minus 8 over 3. That's what you'd say, right? 4 minus 8 over 3, which leaves you at 4 over 3 pi r squared. So then you become like this, 4 over 3 pi r squared plus pi over 3r. And that's what they wanted. I'll show you now in the next slide. That's what they wanted. They wanted the surface area to be written in this context. Okay. The last part, okay, no problem. The last part is 4 pi r squared plus pi over 3r minus 4 pi r squared over 3. And I'm saying these guys are the same. These two, like terms. And I said, why don't you think about it in terms of 4x minus 8 over 3x? If you were to do that, the answer will be 4 over 3x. That's what it is. It's like saying 4 minus 8 over 3, then you put the x. Same thing. I said 4 minus 8 over 3, then I put pi r squared. And that's how it ends up on that aspect. All right. So that's your answer for that one. I want to take this out and I'll show you what they wanted. Exactly what I just put across is what they wanted on the next slide. Follow me on the next one. Gone. Perfect. Then you've got 10.3, which says calculate the minimum outer surface area of the satellite. So this is what they wanted, remember, for 10.2. And then now they want 10.3. Just right. Give me a second. I just want to stop the sharing. Move that annotation there. Should be able to see the screen now. Calculate the minimum, all right, outer surface area of the satellite. Oh, let's do some maths. Minimum outer surface area of the satellite. Okay, family, let's work it out together. The formula for surface area from what we see is 4 pi r squared over 3 plus pi over 3r. That's what they say. Then on this part, I want the minimum outer surface area of the satellite. So which means I'm going to use the surface area formula, but I'm going to do ds over dr. Notice that pi is a number. Pi is just a constant. So it's ds over dr. That will be equal to 0 when we've got the minimum outer surface area. And so from here on, I can then quickly say S is equal to 4 over 3. Look, I'm trying to arrange it properly, algebra, like this, plus pi over 3 r to the power negative 1. I will say, how did you do that? What do you mean like this? Let me show you basics. Simple, right there. Pi over 3r is as good as saying pi over 3 times 1 over r, which is basically pi, let me erase this, which is basically, let me write this down, pi over 3 r to the power negative 1, which is what I have here. Okay, so that would be a side note to remember. So 4 over 3 pi r squared plus pi over 3 pi r to the power negative 1. That's my situation. Now, let's derive. Let's do the maths. When I derive this, remember it's ds over dr. Pi, this is your coefficient. That's your coefficient. That's your coefficient. So 4 over 3 pi r squared. So power times coefficient. That becomes 8, because 2 times 4 over 3 pi, 8 pi over 3 r. Then minus, because negative 1 will multiply this, minus pi over 3 r to the power negative 2. That's ds over dr. And then this whole thing is supposed to be equal to 0, because I'm looking for minimum 8 pi r over 3 minus pi over 3, check this out, r squared. Because right now it's a power of negative 2. When you get it to the bottom, it becomes positive 2. And so we can do the maths now and continue and say, in this case, I can take this to the other side. So it becomes pi over 3 r squared, algebra, 8 pi r over 3. I can cross multiply. 3 pi is equal to, cross multiplying here. So pi times 3, then 3r squared times 8 pi r. It becomes 24 pi r cubed. I need to 3 times 8 is 24. R squared times r is r cubed, then pi still remains. I'm looking for the minimum outer surface area. So I need to find r and take it back to this original. I get the minimum outer surface area. I can divide both sides by 24 pi so that I can find r. 24 pi, follow my maths, is equal to r cubed. Then it becomes in maths 3, or let me not say 3, 1 over 8 actually, because I need double pi, they'll cancel out. So 1 over 8 is r cubed. Then I bring it here. The value of r cube root of 1 over 8, this becomes 1 over 2. All right. The green part, I just took this to the other side. That's all. I took this, it made it into pi over 3. r squared is equal to 8 pi r over 3. That's what I did. Then from there on, I just cross multiply. So I said, use a different color pen. I said this 3 times pi, and I said 8 pi r times 3r squared. End up with 24 pi r cubed. And then I'm looking for r, so I can get the minimum outer surface area. And so I divide both sides by 24 pi. I get up 1 over 3. 1 over 8 rather is called r cubed. Then I cube root. R is a half. So it means when r is a half, that's when I get the minimum outer surface area. But they want the actual surface area. Calculate the minimum outer surface area, not the value of r when I have minimum, rather the minimum. So now I've got 4 pi r squared over 3 from the original plus pi over 3r. Substitute 4 pi r is a half, that's squared, over 3 plus pi over 3 times a half. That's what I have right there. Then from there on, you can play around with the maths. And then once you play around with the maths, you should be able to find that the surface area that you get minimum is actually pi square meters. Your answer is pi, actually. Or if you wanted, you can make it into 3.14, because that's the value for pi, square meters. All right, and that is your maths. Welcome to school. Application to calculus. Talk to me. All right, somebody is raising their hand. Go ahead. I'm all ears.
Sir, I got lost from the beginning when you said that it's on the red, wait, on your left where there is red.
The first,
Right?
this part.
Yeah, when you said, yeah, that part when it's plus pi over 3r to the power negative 1, I thought it was going to be 1 over 3 pi r.
No, let me show you from basics. When I say 2, please understand the difference between x over 2 and 1 over 2x. Those are two different things. When I say x over 2, here it's like half x. And it's,
Yes.
when I say 1 over 2x, it's like 1 over 2 times 1 over x. Do you see that?
Oh, yes.
1
Okay.
over x is x to the power negative 1. So it's going to be a half x. That's what I did there. Exactly that. That's what I did.
Okay. I understand now. Thank you.
All right. Talk to me, family members. What's happening? That's the math. And the answer is pi. Like that. Just like that. All right. Having said that, I think people are done copying. Okay, a couple of hands. The yours, I'm yoing, son. Come on, people. Friday is looking bright. It's going to make it. You're going to make it. Going to be fine. Stop the bus, Baba. Where are we going? Stop the bus. Guys, it's not difficult. I tell you this, it's algebra. It's algebra. I cannot, for the life of me, keep telling you how important this topic is. Algebra. Algebra. Yo. It is everything right there. Everything as you would expect. All right, fam. That's just our question. That's just everything in that aspect. Let me stop sharing because I want to stop right now. Thank you so much for attending today. I just want to remind you of one thing, that you guys are able to attend my classes. I'm going to do some online revision. I'm just looking for the slide. Yes, I found it. Let me share it. All right. I'm going to be doing this online revision. Is it? Yeah. This online revision to prepare you for Friday, this examination. That's going to be big, where application to calculus will be. All right. So this is going to be quite something. Tomorrow, between 7 and 11 in the evening, circle and analytical geometry. Wednesday, the 1st of November, functions, then calculus. Then on Sunday, we're going to do 2 topics, Euclidean geometry and trigonometry. If you're interested, I'll send a link on the group. If you don't, or if you're not in any of my groups, here is my number. And I'll say it out even to the YouTube family, 073974. So let me write it down here. All right, 0739748498. And just text me on WhatsApp. Then I will pull through. I'll send this recording on YouTube soon enough. Let me just finish it up here, and then we'll take it up from there. Thank you so much, fam. I love you all. I know you're going to make it. I know you're grateful for these free lessons, but hey, in life, things are not free, but fair, so please understand that it's not all the time when I will be doing this whole thing, right? The massive revision definitely is going to take place. It's going to be your salvation. We're going to do a lot there. Thank you, fam. I'm going to stop the recording. Then we just say chit chat to each other, and that's it. Stop recording.